times 1 plus r over n to the nt. But since it's compounded annually, so they're just simplifying it. What does n equal? 1. So what is this reduced to? So we'll use n equals 1. So our final amount will equal the principal times 1 plus r to the t power. So when n equals 1, it simplifies a little bit. All right, where's the 22 million go? A. 22 million is your final amount. So that goes for A. Principal, 5,000. We are looking for R. The T will be the 54 years, the time it takes for 5,000 to turn to 22 million. We haven't done this before. One thing you can't do, and there's a temptation, to take this and say, oh, I'm going to make that 1 to the 54th power plus r to the 54th power, basically saying that 54th power goes both of them. That does not work. Why not? Because you have to write out 1 plus r how many times? And then multiply those all together. It's not going to be 1 plus r to the 54th. Okay? So you got to be careful there. That doesn't work. So we're kind of stuck. One thing I would suggest you do, move the 5,000. So divide both sides by 5,000. We can do that. And what's 22 million divided by 5,000? 4,400. So we get 4,400 equals 1 plus r to the 54th. All right, what if I had 4,400 equals 1 plus r squared? What would you do to solve it? Square root. All right, what are we going to do? 54th. Take the 54th root. Okay, so we can take the 54th root of both sides. So it's no different, except you're just not used to it. So I'm going to take, let me write that a little bit neater. The 54th root of 4,400 equals the 54th root of 1 plus r to the 54th power, which will leave me 1 plus r. Now you may or may not know how to use the 54th root on your calculator. Okay. It is under math. And if you take a look there, number 4 is the cube root. Number 5 has a little x there. It means you can put in anything you want for that root. You have to type it in first, though. Of course, if I go to 5, well, what was the problem? Whatever my answer was, it's trying to use that as the root, and it wouldn't take it. So I got to go 54, and then I go math, number 5, and then I go 4,400. I don't want to round off yet. So I got to take that, and what do I have to do to get r by itself? Subtract 1. Okay, so did it take it? Oh, well. So I'm going to just put down the 54th root of 4,400. And then I'm going to subtract 1. Now I'm going to round it to 0.1681 equals r. What was that as a percent to the nearest 100th? My book listed as final answer 16.81%. So r, the annual rate of return is 16.81% for that. All right, I want to show you, there's another way to do that other than the 54th root. It's a similar idea. So once we get to here, 4,400 equals 1 plus r to the 54th. you can take it to a power. It's the same idea as doing it as a root. And let me go back to my x squared issue. So if you got x squared equals, I'm just going to make this up, 10. And I usually take the square root. What power is the same as the square root? Like square root of x is really x to what power? I know we've gone over this. Not negative. Square root's the 1/2 power. Okay, square root of something the same as x to the 1/2. So instead of taking the square root, I can take both sides to the 1/2 power. Because what happens to the 1/2 times the 2? That gives me 1, 10 to the 1/2. What power then would I do the 4,400 to both sides? I'd take it to the 1/54 power. Same thing. So I would do 4,400. Sometimes this is actually easier. 54 equals, and then I would take 1 plus r to the 54th power, like that. And so if I do 4,400 to the 1 divided by 54, I end up with the same thing as taking the 54th root. Okay, you haven't done that much or before, so I just want to make sure we covered that. So 16.81%. Now, compound interest, things like this, it takes time, but once you get it for a lot of time, things really build up. So 54 years is a long time. Moral of the story is if you can start putting money away, the earlier, the better. Okay, so even if it is $1,000, 500, whatever, 2,000, put that away. Figure out how much would she have after 10 years using that information. After 10 years, what would she have had, that $5,000? So now you got your amount equals 5,000 times 1 plus 0.1681 to the 10th power. Just round it to the nearest dollar. Kyle, what did we get?
23,646.
All right, and is that close to 22 million? No. After 10 years, it's only gone from 5,000 to 23,000. It's still a significant amount, but it's nowhere near close to that. All right. Also, when you're doing this, you can just make this on the inside 1.1681, because that's what you're going to get when you add those. Figure out what she has after 30 years. Make a mental guess before you hit enter. What do you think she has after 30 years? Kyle, what she got after 30 years?
528,896.
896. So even after 30 years, all right, that's a significant amount, but is that anywhere close to 22 million? No. So if you just keep it going, keep growing it, then it obviously keeps going up. And so the time is a big factor. The longer you can let it sit there, the greater chance you have of letting it accumulate. All right, so that's why the earlier you can start, the better for anything with savings. All right, take a look at 107. 107. And some of this, I think, just might have been a little bit of confusion on the wording of the problem. Bank A is better than Bank B, and you needed to be able to justify it is better by $20.72. If you were close, that's not good enough. It needs to be $20.72. Now, to understand the situation, Javier wants to transfer $1,000 from a high-interest credit card for a period of 12 months. He's got two offers. Now, this is honestly pretty common. They'll do a transfer. So, like, some credit cards can be anywhere from like 18, 19 to 22, 23%. And they'll say, all right, we transfer it to our credit card for 8%, but you're going to charge you a fee. In the end, you're probably going to save money. But you got to figure out whether you will or not. Bank A, is it 8% for compounded monthly, right? But what's their fee? Is it 2%? So you get a 2% fee. Bank B charges 6% compounded monthly, but what's my fee? 6%. All right, is this money we owe somebody or is this money we're saving? Do we understand? Is this money we owe somebody, Carter?
You owe somebody.
We owe somebody. So in the end, do we want, what's going to be better, the lower amount or the higher amount? Lower amount. We want the lower amount because we're paying somebody. Now, the key sentence here, which a few of you misinterpreted. Assume in both cases that the initial transfer fee is being added to the principal. They are charging you a fee to do this. The first one is 2%. So what is 2% of $1,000? 0.02 times 1,000 is 20. So now they add it to the amount you owe. So you now owe how much? $1,020. So we owe 1,020. 6%, 0.06 times 1,000 is $60. So now you owe 1,060. So you got to use those in your calculation. Now, I don't think the problem was worded great. It wasn't worded horribly, but I think there's a little bit of confusion here. So basically, you're going to say the amount will be 1,020 after 1 year times 1 plus 0.08 divided by 12 times NT, but T is 12 months, which is 1 year. So this is what you should use to calculate that. And then over here, it's going to be 1,060 times 1 plus 0.08, no, not 08, 06 divided by 12 to the 12th power. Okay. Some of you subtracted the fee off of that amount as opposed to adding. All right, who's got this format? I know a few of you had that correct. Who's got that? Carter, what do we end up with for A over here?
$1,104.66.
What was the cents?
66.
66. And what do we end up with for over here?
$1,125.38.
All right, so in this case, we want the lower amount because it's money we owe. So we want the 1104. We want Bank A. And if you take 1125.38 minus 1104.66, that is where we get the $20.72. Okay. All right, I want to do 101 where you had to find the R value. I wanted to go through this one because several of you, I think the wording was a little bit confusing and it was just a different situation. All right, double check your answers for 78 and 82. 90 is a graph. That's one you can just check on your calculator. Any questions on any of those? Okay, we're just going to start this guided notes. We're not going to get anywhere near through them, but let's just go ahead and get them started. Ooh, we're barely going to get started. All right, I want you to do a couple things here. Graph, do me this favor. On that grid, you're not going to have homework tonight, so don't worry about that. Graph 2 to the x on, I already have it graphed up here. I'm going to make an XY chart. We've done it a couple times. Do it again. -2, -1, 0, 1, and 2. 2 to the negative second is 1/4. 2 to the negative first is 1/2. 2 to the 0 is 1. 2 to the first is 2, and 2 squared is 4. Plot those points, draw in your curve. Okay, now on that same set of axes, I want you to graph the inverse function. And we don't have the equation for it, but we don't need it. Remember what you do for inverses. Whatever xy is on the original, yx is on the inverse. So we're just going to flip the ordered pairs. So for the inverse, okay, I get 1/4 would be my x negative. Whoops, I got that backwards. -2 is my y. 1/2 is my x. -1 is my y. 1, 0, 2, 1, 4, 2. So let's see here. 1/4 -2. 1/2 -1. 1, 0. 2, 1. 4, 2. And when I graph it, and remember they flip their domain and ranges. The domain of the original function is the range of the inverse, and then the range of the original is the domain of the inverse. Also, you got, it is also a reflection about the line y equals x. Not that you have to draw that in there, but that just gives you a visual, so it flips over that side. The second one does not have a horizontal asymptote, but now it has a vertical one. All right, second thing I'm going to ask you to do, what is the equation of the inverse? Okay, come up with its equation. All right, take a second and think about that. Now for your equation, so we started with f of x equals 2 to the x. And so we just make that a y. And don't forget for inverses, remember what you flip? Flip the x and the y. So now that becomes x equals 2 to the y. All right, what's our goal? Get what by itself? Y. All right, how do I do that? Do what? You gotta use logs. You cannot do algebra, like you can't take it to the y power, anything like that. So basically we're kind of stuck. So we're going to develop logs. The actual equation for the inverse is log base 2 of x. That is your equation. All right, we'll finish this tomorrow. Yes, tomorrow we'll go over this. We'll talk more about logs.
And that's why like my brain is just about.
Literally came to school 2 hours
I don't
later.
think what? I got up at 7.